So, like coming to this term deep learning. So this is the subset or the hierarchy diagram. So we on the top we have artificial intelligence. So artificial intelligence is nothing but providing the ability to machines, like enabling the machines to mimic human behavior. And the best example would be like robots nowadays. You see robots, they can walk like humans, they can talk like humans, they can do movements like humans. So this is what artificial intelligence is about. Inside artificial intelligence, we have a subdomain which is called machine learning. And machine learning, we saw like we give the machine the ability to learn by itself without being explicitly programmed. And within machine learning, we have a subset which is called deep learning. And deep learning basically tries to mimic the behavior of the human brain. So in human brain, we have something called as neuron, and deep learning tries to implement, like convert that neuron, biological neuron, into a mathematical neuron. So here I have added the theory related to artificial neural networks. I'll move into the slides. Here I have made some slides as well. So I'll walk you through what is neuron and explain what. So I hope my slides are visible to everyone. So this is the image of neurons which we have in our brain, and neurons are responsible for whatever actions we take. So whatever happens externally, like our sensory organs, they are called as receptors, and we we use our sensory organs to sense, and based on that we our neurons in the brains pass on those signals as in the form of electrical impulse, and we take the actions accordingly, and our brain directs us to take the action accordingly. So this is how neurons are connected, and here there is a process which happens which is called synapse. I'll explain you in more detail here. So we have the cell body here, and here it goes our input or whatever our sensory organ sensed. For example, your eyes saw fruit, say apple, in front of you. So it will send a signal to your with the input, whatever I see, image that is found on retina will be sent as an input. Here it will go to the cell body, it will go to the nucleus, and it will pass on to the axon. And the axon here it gets passed on to the another neuron through the process called synapse. Here which passes on the electrical impulse. You see, they're not interconnected here. There's some gap, and this is how our biological neuron works. So our mind then tells us that yeah, this is a fruit, and this fruit is an apple. Now, what researchers and scientists did is that they used this concept of biological neuron, and they made a model, a simplified mathematical model, which is similar to this. So you have in your input here, then you have a neuron here, and then you have your output here. Now, why are we talking about this neural networks and deep learnings and why there is so much of hype right now nowadays? So the reason is as the years passed by, the amount of data we have has increased exponentially, and we have heard of phrases like data is the new oil, and like data is everything now. We have the words like big data in the market, and we have jobs related to that. As the data increased exponentially, we what we observed is that the traditional AI was not able to perform much better, even we were feeding a lot of data. But as the neural networks were introduced, we saw that there was a visible increase in performance as the amount of data increased. And when we used a medium neural network, there was even further increase in the performance if there was huge billions and billions of data. And large neural networks, they were able to do typical tasks like you see object recognition nowadays, or computer vision applications, or you have this chat gpts, the text text based applications. So By making the use of faster computer processors and good hardware, we saw that there was like a rapid increase in the performance as the amount of the data we were feeding in increased. So that is why nowadays we're hearing a lot about deep learning, and it's the era of deep learning and big data. So I'll take an example. So I'll use a classification example. Suppose you are a shopkeeper. Again, I'm making you all a shopkeeper. And suppose if you're someone selling some nice cool t-shirts or shorts. What you want to know is that this new t-shirt or short by your own brand, whether it is going to be a top seller or not. This is what you want to predict. So basically, you want to predict the demand. So if the demand is one, then obviously your t-shirt, whatever you're manufacturing, is going to be a top seller. So it's a classification problem where we need to answer either yes or no. And if we were to do this using logistic regression or the traditional ML algorithm, we would have like used logistic regression most probably, wherein we have used, which is based on using the sigmoid function. Now, this what we would have done is we would have given the input, we would have fed this to the sigmoid activation function, and if the value was greater than threshold, we would have marked as yes, it is a top seller, and if the value was lesser than threshold, we would have marked it no, it's not a top seller. So this function, sigmoid function, in deep learning technical jargon or term is known as activation function. And we'll be using this neuron here is nothing, but it's just a logistic regression implementation. So you have your X here, you pass in your input here, and you have this activation function which gets computed, and here you have the probability of being a top seller. So this is the simplest model of deep learning, and this model is also known as a perceptron model in case the activation function we use is a threshold activation function. And this is a deep learning like neuron model with one single neuron, one single input, and one single output. So I'll tell you, we have different kinds of activation function. We'll see them within a while. So this is the problem statement. What is it about? Now you saw the simple model of neuron. Now if I move further, what if you were able to include more input features and you were able to include some semantic features as well? For example, you considered other features like price of the shirt, the shipping cost, the marketing done for that t-shirt to make it a top seller, and the material used in that t-shirt. Now, with the price, we have a term no associated known as affordability. So, is your short affordable by the masses or the group of people who buy from your shop? Um, was the marketing able to create enough awareness? Is the material of enough good quality? So, if you were able to add these additional features as well, it would have resulted in even being a better model, or it would have been resulted in making your model more robust, which gives the most accurate predictions. And it would be an added advantage to you as well. For example, just take a human example. If you visit a shop, if the shopkeeper asks the feedback from you, if it takes he or she takes the feedback, he next time if you visit the shop again, he'll be able to cater you better than what he did when the first time you visited the shop. So it goes that way. So this is why we can have like multiple layers here. We can have multiple neurons here, and that is the reason why we have multiple neurons. So in case we have multiple layers or multiple neurons, our architecture looks something like this. We have our input layer, we have the hidden layer, and then we have our output layer. Now, what I would show here is in a typical neural network architecture, what we have is we have our input values and we have some weights associated with these input values. Now, these weights can be higher or lower. Suppose if we want that price should influence the top seller t-shirt being the top seller more rather than quality, suppose. So we can keep the weight associated with the price higher than the quality. or we can do vice versa. So once we have these values, we can compute the sigmoid function formula and we can predict the output. So this is how it goes. Now, once we have our output value, you know what happens is we might not always have the value that matches it completely very well, matches it correctly. So we might get some error. There must be a difference between the actual value and the predicted value. So in case there is a difference, what happens in artificial neural network is whatever error is there using some optimization algorithm, like we use gradient descent, which is most famous algorithm, or we use Adam optimizer. You'll learn about optimizers more in great detail in the session of deep learning. So using that optimizer, we recompute the weights here. We recompute the weights, and then again the activation function is you is calculated, and again the value of y is predicted. And this process goes on until we are satisfied with our algorithm, or we are, until the number of times we want this process to occur is satisfied. So this is how the this is like the entire basic or the entire intuition behind the deep learning and artificial neural networks. So I'll show you some examples of activation function. We have threshold activation function, which gives says the value to be 1 in case the x is positive and the value to be 0 if the x is negative. We have sigmoid activation function, which we have already learned and covered in classification algorithms while we were studying classification algorithms and we studied about logistic regression. Other than this, we have a very famous activation function, which is ReLU activation functions, also known as rectifier linear unit. So it takes the function is like it takes the maximum of the current x or 0. And then we have this hyperbolic tangent and activation function. And all these activation functions have different significances. So for example, a sigmoid activation function is used mostly when we are solving the classification problems. ReLU activation function can be used when we are dealing with regression problems and where we don't expect the value to go negative. For example, if we are predicting the price of the house. So in that case, the house of the price of the house can never be negative, right? So we can make use of ReLU activation function there. And we'll see how we actually use this in code. So this is it. Now coming to the optimization algorithm, I'll just give you an idea of what optimization algorithm is about. So suppose you got the value of the output here, you have your model, you computed the value of y, you got some value. Then you computed the difference between the actual value and the predicted value. And you plot it here, you plot the difference here and the actual value here, and you got the error or the loss, something like here. Now again, since you're implementing gradient or descent or you're doing something, you're using some mathematics, you recomputed the weights and then you got the new value of y. So you see the cost got reduced or the loss got reduced. So once you keep on repeating the process, you will reach a point where that value of y which you predicted would be the best value. And in case you keep on refining it, if you keep on changing the value, you see that results just keep on getting worse or the cost increases. So you'll get something like this in the shape of bowl or this curve, something like this. So what your goal is that you need to reach this point. So this is what gradient descent does. So it runs and it computes the cost and it finally stops at the point where the cost is minimum. And how does this happen? So it makes use of mathematics concepts like a differentiation and it computes the minimum. You have heard about global minimum. It computes the global minimum and here it converges. So this was like introduction to the optimization algorithm, and we've covered the introduction to artificial neural networks. So, but I'll now just won't take your much time, and I'll walk you through an implementation of artificial neural network. So the very first thing we do in the code, I hope my screen is visible here. So what we do is we import the libraries as the very first step. We import NumPy, Pandas, and TensorFlow, and then we start like we import the data set. So the data set which I have taken here is it's a churn modeling data set. So what does churn modeling means is we need to find out how likely is this customer to uh, no, like how likely is this customer to churn or leave this bank. So we'll not issue the bank will not issue the credit card to that person. So basically, the bank people are deciding whether the credit card should be issued to this person or not. He's a good enough person or not. So that is what this problem set is about. So we have the details of the people who are associated with the bank, who have their accounts in the bank, and we have some metrics here. So what we'll do here is that I can show you the data set. Yeah, just a second. So this is how the data set looks like. So you have the customer ID, you have the surname, you have the credit card score, you have the geography, the gender, the age, tenure, balance, number of products. Does he has the credit card? Is he the active member? What is the estimated salary? And what is the chance like the customer exits or stays? The one stands for the customer is likely to be exited, like he'll not probably is not a good candidate for the bank, and zero is he'll not exit. He's probably likely to pay his bills and debts and loans all on time. So again, coming to the code, I showed you the data. I'm not going again through the pre-processing steps. We've already covered it all in great detail. So we're importing the categorical data. Here and I've used label encoder, and here I've used one hot encoding for the another column. And once we have encoded the data, we make the train test split here, and we have considered 20% of data to be the test data and 80% of data to be the training data. Now, further, I've performed feature scaling. So I've used normalization here so that the entire data set is properly scaled up. Now comes the main part, building the artificial neural network. So in order to build the artificial neural network, you first initialize the ANN model. So as we've imported TensorFlow, we hit the sequential API and we create an object of sequential API. Once we have hit tf.keras.model.sequential class and we have created an object of this class, what we can do is we can add a first layer here. So what we are doing is we are adding the first layer and we are saying that we want 6 neurons and the activation function, like what we are using for that neuron should what the neuron should compute. We are using activation function as ReLU, and it's widely used, like ReLU is widely used when solving problems in ANN. And there can be cases like you can try it with a TANH or another activation function. Now, once we have added a first input layer and the first hidden layer, we'll go and add a second hidden layer. And the second hidden layer also has 6 neurons, and the activation function, again, I've used ReLU. Now, since you saw that the data set, we are finding whether the customer is likely to exit or not. So it's classification problem. So the output layer, what it will have a single neuron, and we'll make use of sigmoid activation function, wherein we just want our answer either it to be a 0 or 1. So this is how our output layer looks like. So once we have these layers separately. What we need to do is we need to compile this model. We need to connect these layers. And for that, we have compile method. And in compile method, we pass in our optimizer as pass in the optimizer. So you can try with the gradient descent, which I told you. Adam is another optimizer, and it's an advanced and very nice optimizer. So I would suggest you all to go and read about Atom. And we compute the loss at every step. So as I said, the difference between the actual value and predicted value will compute the loss. And here we have taken binary cross entropy. Binary cross entropy is nothing but the loss we calculate in the logistic regression function that I showed you yesterday. It's known as binary cross entropy in deep learning. And the final metrics which we use for evaluating how good is the model, we use the metric called accuracy. So if you have gone through the classification notebook yesterday, which I've shared, and the assignment which I gave you, you would have seen some notes on accuracy as a metrics for the classification problem. So this is it. It's all same. Now, once we have compiled our model, we have specified these values. The next step which we do is we need to fit in our model. So for fitting in our model, like we need to tell the model, like, hey, this we need to fit in according to the input data which I'm providing. So I provide the training data, and here you see two terms, batch size and epochs. Now, what epoch is basically one full cycle through the entire training data is known as epoch. So once your device completed for all the training data, we call like it has completed the entire pass through the entire training data set. We call it as one epoch. And what happens is when one epoch is completed, the weights get updated. But in case the data set is huge, if we wait for the epoch, one whole epoch to run, it might take some time. So what we usually do is that we divide the data set into batches, and we perform multiple iterations. Now, what a batch is, we can consider or specify the batch size. Here, I have taken the batch size to be 32, which is even the default batch size. So at a time, only 32 samples from the data set will be picked, and we'll go through forward and we'll compute the value of y, and then the weights get updated. So for example, if you have 1,000 training samples and you set the batch size to be 500, you need two iterations so that your one epoch gets completed. So I've added this theory so that you can read it, and it makes you clear about the concept of batch, iteration, and epoch, as a lot of people are confused in these terms and terminology. So once I call the fit method, what you observe here is that in the first epoch, the accuracy is somewhat 85, and the loss here is zero point 0.3. Now, as I go further, you will see that the value of loss keeps on decreasing. We don't have a huge data set. Won't see a subtle, like you see a sudden increase in the accuracy and decrease in the loss. If you were dealing with a heavy data set, large data set, you would have observed a lot of changes here. So at every step, you see there is this change in accuracy, and the loss keeps on decreasing, and the accuracy keeps on increasing. And at the end of the last epoch, you have the final loss and the final value. So you can see the loss and accuracy to be here. You need to decide the optimal number of epochs. If you keep the epochs very high, if you use a lot of epochs, then it might not be the case that it gives you very good result. Usually, you need to decide based on your data, based on your business use case, based on your understanding what should be the number of epochs or how many times do you want this algorithm to run. Now, here I've used the summary method just to show you how the model looks visually. So we have a first layer. We have herein we have your inputs present, and batch size is 32. So you see here 32, and we have 6 neurons. There are total these many parameters associated with this layer. We have a second hidden layer here, and this is our final layer called dense 2. It's our output layer. And this is the entire information about our model. So you can use summary to get an idea what kind of model you're building. Now, once we've built model, we have used the model, we have fit the model according to our problem statement. We will make predictions and we'll evaluate the model. So for you, the homework is like you need to go to this notebook entirely. You need to understand the code, and you need to predict uh, that whether the person who has these values, this information, is he likely to make an exit or not? And if we like yes, if exit is yes, then it means like we should say goodbye to that person. So you need to answer this question. I have provided a code block. You need to write it. It's a single line of code. You need to write in here. So this would be your assignment as well. So what I've done here is I've predicted the tested results. So here what I get on using the predict method is we get probability. What I wanted, the threshold, what I've used here is I've set the threshold to be zero point 0.5. So in case if the value or the probability is greater than zero point 0.5, I set it as 1, otherwise I set it as 0. And I'm making confusion matrix and I'm using accuracy score to predict what is the accuracy. And you'll see on the test that we get an accuracy of 86%, which is not a bad accuracy, nice accuracy, which we've achieved. And this is our confusion matrix. We see that there are 74 and 201 uh, true positive, like false positives and false negatives. So this is it for the introduction to artificial neural network, and this is your code notebook which you can go through. So I've kept it simple, and I hope you got an idea of basically why do we need deep learning, what is deep learning, and what is artificial neural network. Now I have one notebook which I was showing here. So here you can read about artificial, like the deep learning more in detail. So I've stated why deep learning, whatever I explained, I've mentioned it here. I've mentioned the diagram. I've mentioned the activation functions. Then there is something called densely connected neural network. Basically, if all the neurons are connected to each other, then we call it as densely connected neural network. And then you have convolution neural network, which are used to deal with the image or the video data. And there is recurrent neural network, which deals with the like you have audio and speech processing, audio text processing. So herein we use recurrent neural network for such use cases. So you can go and read all these in details, and all these would be covered in great detail by Swati from Monday. So I hope this session was good enough and you have all have learned something new. And I would like to keep today's session short as I would like to end up machine learning introduction here, and I've covered probably all the important things that were required that you all guys should know before you move on to further advanced topics. So I hope I was able to add some value to your life, to your knowledge the past 3 days, like today and the past 2 days, whatever you've learned. If you have any questions, then I would want you all guys to ask me. Otherwise, we can end this meeting right now. Okay, Yaban, I'll share the notebooks as well. Yeah, I know it would require some time to get you all through this information, but if you go and read on these notebooks, and if you have any doubts, then you can always ask me. You'll get through this as well. So, yeah, thank you all for this session, for attending this session. I'll share the assignment as well as I'll share the notebook as well, all the notebooks. Thank you so much. Yes, you all guys also have a very nice day. Thank you. I would end the meeting.